Hello everyone, and thank you for joining us in today's webinar. My name is Abdel Jabbar from Grandstream Support. In today's webinar, we're going to talk about the wireless endpoints deployment. And these are the points that we're going to cover in today's webinar. So we're going to have a product overview of the Grandstream access points and the Grandstream SIP endpoints that support Wi-Fi connection. Then we'll have a general look at the GWN Cloud, the Grandstream provisioning platform. Then we'll talk about some basics of the wireless deployments. Then we'll see the tools available on GWN and also some third-party applications that you can use to help you troubleshoot your wireless issues. So Grandstream has a wide offering of indoor and outdoor access points that are designed to serve small to medium-sized businesses such as offices, health clinics, enterprise facilities, and even residential. And they offer high-performance networking with up to more than 1 gigabit, great Wi-Fi coverage range, fast and easy provisioning and management thanks to the built-in controller, and support also for a large number of wireless clients per access point. So we start with the indoor access point. So the first model is the GWN 7615, which is scheduled to be released this month, and we'll have these options: 200 clients and coverage of 175 meters and a throughput of 1.75 gigabits per second. You can use the embedded controller to manage up to 50 other access points as slave APs. This model is built with 3x3. In other words, it comes with 3 antennas for reception and 3 antennas for transmission using the multi-user multiple inputs, multiple outputs, or what they call MIMO or MIMO technology. Next is the compact Wi-Fi access point, GWN 7602, which is designed for small businesses, homes, offices, hotels, and more. It provides 3 fast Ethernet ports to provide wired connection to devices like IP phones, computers, and any device that basically requires an Ethernet connection, while also providing an uplink gigabit network port with the PoE and PoE+. The GWN 7602 offers dual band Wi-Fi 2x2, so this one has 2 antennas for transmission and 2 antennas for reception, which provides 2 streams. And this model uses the single user MIMO technology and supports up to 80 clients and 100 meter coverage range. So to explain what MIMO or MIMO is and how it works, without MIMO, the access point will be able to send and receive data from only one access client or one wireless client at a time. So the more devices that connect to the AP, the longer the wait time becomes. There are 2 types of use in MIMO technology. There's the single user MIMO and the multi-user MIMO. So for the single user MIMO, which was introduced in the 802.11n standard, allows APs to use multiple streams for transmission and reception depending on the available numbers of antennas. For example, the GWN 7602, which uses the single user MIMO technology, has 2 antennas for transmission and 2 antennas for reception with a total of 2 streams. So if 2 wireless clients are connected, the GWN 7602 will dedicate one stream to each client. However, the limitation of single-user MIMO is that the GWN 7602 will only be able to talk to one wireless client at a time. On the other hand, the multi-user MIMO technology, which is used by all the other GWN access points, was introduced in the 802.11ac standard. And as I mentioned, it's supported by all the other GWN access points. So if you want to take advantage of the multi-user MIMO, make sure you enable the standard 802.11ac. And basically this technology, the multi-user MIMO, it allows the access point to talk to multiple wireless clients simultaneously by using a separate stream for each device, which improves the Wi-Fi experience of the users. So next we have the GWN 7630, which is a high-performance 802.11ac Wave 2 Wi-Fi access points designed for small to medium-sized businesses, multiple floor offices, commercial locations, and also branch offices. It offers dual-band 4x4 multi-user MIMO technology and the sophisticated antenna design for maximum network throughput of 2.33 gigabits per second and expanded Wi-Fi coverage range of up to 175 meters. This model can handle up to 200 concurrent wireless connections at the same time. And then we have the smaller model, which is the GWN 7605. This one is ideal for small to medium wireless network deployments with medium user density of up to 100 clients. It offers dual band 2x2 multi-user MIMO with beam forming technology and a coverage range of 175 meters. And one thing about the GWN series is that all the models except for the GWN 7602 has an embedded controller that can manage up to 50 slave access points. And in terms of the number of supported SS IDs, let me go back here for a second. In terms of the number of SS IDs supported by each access point, the GWN 7615 and GWN 7630 can be configured with up to 16 SS IDs. And for GWN 7605, you can have up to 4 SS IDs, up to 8, and GWN 7602 can have up to 4 SS IDs configured. So for the outdoor access point, we have the GWN 7600 LR or long range, which is a powerful long range Wi-Fi access point featuring weatherproof casing and heat resistant technology. It comes with dual band Wi-Fi 2x2 with beamforming technology and extended Wi-Fi coverage range of up to 300 meters, and it supports up to 450 wireless clients. Next new model is the GWN 7630 LR, designed for medium to large businesses and enterprises that need to provide long-range coverage in both indoor and outdoor spaces. It also offers weatherproof casing and heat-resistant technology. And this one is built with 4 antennas for transmission and 4 antennas for reception, which makes it available to handle 4 streams at the same time. It supports 200 clients and an expanded 300 meter coverage range. And to ensure easy installation and management, the GWN 7630 LR includes an embedded controller with the within the product's web user interface, and the same thing applies to GWN 7600 LR. So all the Grandstream GWN 7600 series are supported by GWN Cloud, which is the Grandstream free cloud Wi-Fi management platform. They also offer QoS, advanced QoS actually, mesh networks, wireless bridges, captive portal, social media authentication, and many other features that you can actually take advantage of using the web interface of these access points. So alongside with the Grandstream Access Points portfolio, we have a wide array of voice and video endpoints that support dual band Wi-Fi. So the first model that we're going to talk about is the GRP series, which is primarily a voice endpoint that provides carrier-grade features and performance. It is designed with zero-touch provisioning for mass deployment and easy management through the Grandstream GDMS cloud platform. So starting with the first model is the GRP 2612W. And one thing to note about this model is that they come in three flavors. That is the 2612, 2612P, and 2612W, which is the one that supports Wi-Fi. So in case you're interested in buying the one that supports Wi-Fi, make sure it has the W at the end. So this one has a small color LCD of 2.4 inches. It supports 2 lines with 2 SIP accounts, and you can use the line buttons with to configure them with virtual MPKs with a total of up to 16 VMPKs. The next model is the GRP 2614. This one has a larger color LCD of 2.8 inches. It supports 4 lines with 4 SIP accounts, and again you can use the line buttons to configure them with virtual VMPKs. So the 4 buttons, you can actually create 4 virtual pages so that you can toggle between the pages using the soft key button. This model has integrated Bluetooth, and it also has a dual LCD screen that can support up to 40 VPKs. So each button can be configured to support up to 5 VMPKs. In other words, you can have up to 5 virtual pages on the LCD screen. The next model is the 2616. This one has an LCD, color LCD of 4.3. It supports 6 lines with 6 SIP accounts. It has integrated Bluetooth, and the same thing with the dual LCD screen that you can configure it with 40 VPKs. And the last model in the GRP family is the GRP 2615. This one has 10 lines with 5 SIP accounts. It also supports Bluetooth, and it is the only model that supports the new GBX20 extension module with the color LCD that's going to be daisy chained to 4 times. In other words, you can have up to 4 expansion modules, which gives you a total of 100 VPKs. And one thing to note when you are using multiple expansion modules with the GRP 2615, just remember to use the PSUs so that these expansion modules can get enough power. Next is the IP video phones. So all the Grandstream's multimedia endpoints have wireless support, which also come with robust touch screens. And the GXV 3300 series is the successor to the popular GXV 3200 series video phones that offer a more defined user interface experience, and most importantly, an increased performance and also hardware capacity that is more solid than the one that was in the previous models. So the first model in the GXV 3300 series is the GXV 3370. This one has a touch screen of 7 inches. It supports 16 lines with 16 SIP accounts. This model it runs on Android version 7. It has integrated Bluetooth and a built-in camera of 1 megapixel. This phone can handle 7-way audio conferencing and 3-way video conferencing using the resolution 720. The next model is the GXV 3380. This model has a large screen of 8 inches and 16 lines with 16 SIP accounts. It also runs on Android version 7, and it has integrated Bluetooth and a camera of 2 megapixel. This phone actually gives you HD resolution. You can have a 3-way video conferencing using the resolution 1080, and also you can have 7-way audio conferencing. And the last model is the GXV 3350. This one has a touch screen of 5 inches. This phone is like the replacement of the GXV 3240. This model supports 16 lines instead of 6 lines in the old models. And this one runs on Android version 7. It also supports Bluetooth. It has 1 megapixel camera, and it supports 6-way audio conferencing and 3-way video conferencing using the resolution 720 pixel. All right, so in terms of the cordless options that support dual Wi-Fi, we have the WP810 and WP820. And the WP810 supports key features such as push-to-talk and multicast paging, while the WP820 comes in a more complete package that includes higher battery capacity and also Bluetooth support. Both devices can be used by roaming employees such as school administrators, warehouse workers, or even executives to perform multicast pages using the push-to-talk button built into the WP800. They are fully integrated with Grandstream Door System GDS 3700, which provides users with the capability to grant access while roaming, and also have the option to unlock the door remotely using the shortcut open door that is supported in both cordless phones. Next, I want to talk about the GWN Cloud, which is the Grandstream cloud-based management platform of GWN 7600 series. It works only with Grandstream access points, and it is available for free. If you just go to gwn.cloud, you can sign up for a free account, and you can start adding devices and managing them from the cloud platform. So GWN Cloud basically offers a centralized management of your Wi-Fi devices, not only for your like for a single site, but also for your entire enterprise. You can manage multiple sites and multiple devices from one central management interface. And it features complete scalability with no limits on the number of sites and access points that you can add and manage from the GWN. Everything basically that you do from the web interface of the access point can be done and managed from the user interface of GWN Cloud, in addition to other features that are not available using the web interface of the access point. It is a very secure option and solution because all traffic between the access points and the platform is encrypted using TLS. Also, thanks to streamlined monitoring and maintenance, managing your network across multiple locations has been made easier with GWN Cloud. It helps wireless administrators keep an eye on the network's performance with real-time monitoring. You can also configure the alerts option built into GWN, so in case there's an event, the GWN Cloud can send you an email with details about the type of events that was triggered. You can also use GWN Cloud to have access to statistics and report that can be viewed using either the web browser or using the GWN application that is available for both iOS and Android. It is also worth noting that GWN Cloud is hosted on AWS or Amazon Web Services, which is a very reliable service. So you don't have to worry about the system going down. So as I mentioned a moment ago, GWN Cloud can be accessed from anywhere using a web browser or the GWN app, which is free and available for both iOS and Android smartphones. So adding GWN access points to your accounts on GWN Cloud is a very simple process. You can add them manually through the user interface of GWN by entering the MAC address of the device and the unique password that comes with each access point, and it is included in the sticker. Or even better, you can use the GWN app to scan the barcode of the access point and add them automatically to your GWN account. So after this presentation, I'm going to have a quick review of the web interface of the GWN Cloud so I can show you the features available from GWN Cloud. So next we move to the wireless deployment and talk about some basics that you need to understand when deploying wireless endpoints in your wireless network. So one common question that is always asked when deploying access points and wireless endpoints like the IP phones is which frequency you should use for your wireless connection. There are two bands known as 2.4 and 5 gigahertz, which have different frequency characteristics. And in general, the main differences between the 2.4 gigahertz and 5 gigahertz bands are speed and range. So while the 5 gigahertz band provides higher data transmission rate, 2.4 gigahertz frequency covers a larger area but sacrifices speed. And also 2.4 is known for being more susceptible to interference because many devices, like non-Wi-Fi devices, use frequencies close to 2.4, such as microwaves, cordless phones, baby monitors, and even if your neighbor's router is using 2.4 and is using the same channel, that can also cause some kind of interference. An example, if you live in an apartment complex surrounded by many wireless devices in your neighbor's apartments, there is always a strong possibility that the 2.4 gigahertz band is congested with all sorts of these devices, including microwaves, Wi-Fi devices, and non-Wi-Fi devices. So besides these basic differences between 2.4 and 5 gigahertz, there are other factors that might determine which band your devices should utilize. So for example, if you have mobile devices that move around a lot over a large area with fewer access points, you might want to use 2.4 because the long distance coverage that it provides, and because 2.4 gigahertz frequency can penetrate solid objects easier than the 5 gigahertz band. But if you have like an video devices or video conferencing solutions, excuse me, like the GXV 3300 or the GVC 3200, you definitely want to use 5 gigahertz because of the fast data transmission that 5 gigahertz provide, and that is also required by video solutions. Another factor is also the number of users that will be supported by the access points. So in a high density Wi-Fi environment with a large number of wireless clients, I would say between 25 and 35 within a small area, it is always recommended to prioritize 5 gigahertz because 5 gigahertz offers more channels than 2.4 gigahertz, which prevents interference while keeping the transmission speed rate high. It is also important to note that it is very likely to have wireless devices in your network that still use the legacy standards like 802.11b and 802.11g, which works only with 2.4 gigahertz frequency. And by the way, I believe 802.11 is disabled by default on the GWN access points. So it's very rare these days to find any device that only supports that standard. But in case you have devices using that standard, you still need to go to the access point and enable this standard so that devices with supporting only that standard can still connect and have a wireless connection using the GWN access points. So this is a list of the well-known wireless standards. So for the 2.4 gigahertz, we have BGN, and for 5 gigahertz, we have AN/AC. Now there is a new standard that they call Wi-Fi 6, which is 802.11ax. So that's a different frequency and a different band that has its own characteristics. That's something like still new for in the wireless world. So because it's very hard to predict sometimes which wireless devices will connect to your access points, and because you don't know which wireless standard the devices support, the GWN 7600 series supports the option that we call band steering, which basically allows administrators to adjust which band to prioritize, either 2.4 or 5 gigahertz when wireless clients try to connect to the access point. And technically speaking, when a wireless client tries to connect to the AP can be configured to prioritize either 2.4 or 5 gigahertz. Or you can just tell the AP to load balance between the two bands. So now that you understand the benefits of each band, you can decide which one to prioritize using the band steering feature. And if wireless coverage, this is just a general rule, if wireless coverage is an issue, you want to go with the 2.4 gigahertz. However, if the wireless network is crowded, in other words, you have so many wireless devices in your environment, you definitely want to go with prioritizing 5 gigahertz. So now that we explained the differences between 5 gigahertz and 2.4 gigahertz, the next step would be to decide which channel to select within each frequency or each band, and also I will show you how to do that. So by default, the GWN series have the channel selection set to auto, but in most cases you still need to go to the web interface of the access point and adjust it. I mentioned a moment ago that 2.4 gigahertz has less channels than 5 gigahertz, and this image shows that 2.4 has 14 channels, including 3 non-overlapping channels. So if you are in North America, especially in the United States, the number of channels is only 11 channels. Japan uses all of them, that means 14 channels, and the rest of the world, I believe they use 13 channels, except some countries. So as you can see, each channel overlaps with 2 or 4 other channels, and this affects the performance of the wireless connection. So the 3 channels that don't overlap with one another in this image are channels 1, 6, and 11. And this is why it is always recommended to use these channels, especially when your access point is using 2.4 gigahertz. If you are in a different country that supports 13 channels, you can still use 2, 7, and 12, or you can use 4, 8, and 13. So these are channels that don't overlap with each other. With the 5 gigahertz, there are way more channels available, up to 24 non-overlapping channels of 20 megahertz. And as you can see in the image, you can make the channels wider to increase throughput. GWN Series allows having channels of 20, 40, and 80 megahertz. So despite the existence of many channels in 5 gigahertz, not all of them can be available for selection. And for example, channels 52 through 144 are labeled with DFS because these channels are also used for military and weather radars. And DFS, which basically stands for Dynamic Frequency Selection, allows the access point to detect if there is any signal from a close-by radar to automatically change the channel, because this is required by the law. You can't put your access point in a channel that is used by a radar and don't have this option, which is the DFS. So when selecting wider channels, you should be aware that wider channels can negatively impact the quality of the wireless signal because of the noise that is introduced into the signal. And personally, I would recommend using channels with the width of channels of 20 megahertz or 40 megahertz in case you want to have more throughput. So there are other things that you need to consider when deciding which channel to use. For instance, when deploying access points in a standalone architecture, you can assign the access points to separate non-overlapping channels. For like you see in this example, one access point is on channel 6, the other one is on channel 1. Also try to use 5 gigahertz channels in a high density environment, again because 5 gigahertz provides you with more channels that you can take advantage of. It is always a good practice to run Wi-Fi analyzer to detect crowded channels, especially when you are surrounded by neighboring access points or wireless routers. You can use GWN Cloud to help you detect the adjacent access points, or you can use a third-party application, one that I'm going to show you at the end of this presentation. To show you just how you can use the application to detect the adjacent access point and to figure out which channels they are using. Another thing is when you have devices of different speed in your environment. There's an option on the access points that you can enable, and we call it Airtime Fairness. So when this option is enabled, it basically gives equal amount of airtime instead of equal number of frames to each wireless client. So this will guarantee that high-speed devices will not get affected by the existence of slow devices that are connected to the same access point. So one element that is used to measure the wireless signal strength is called the RSSI. RSSI basically stands for Received Signal Strength Indicator. It measures how well the wireless device can hear a signal from an access point or wireless router. It is a relative value that is useful to determine if you have enough signal to get a good wireless connection. So the closer the RSSI to 0, the better the signal is. And the input range, I believe in the GWN access points, is from -95 to -1. And to ensure an acceptable wireless connection, the detected RSSI at the wireless client should not be lower than -75. The RSSI is also important because it allows us to ensure that there are no gaps in your wireless coverage, because that could negatively affect roaming users. So to guarantee better roaming experience, the RSSI should overlap at no lower than -75. So when you see that the RSSI is -75, you want to add another access point and make sure that the adjacent access point is also at -75. The APs can also be configured with an RSSI value where the wireless client needs to start the handoff to the next access point with a better RSSI. This is something that you can do at both the access point and the wireless client. So for the access point, this option is available under the client section. So you can go to each client and you can see the RSSI detected by GWN for each client. So you can determine in case the user is complaining about a weak signal, you can go to the GWN and the clients, and then you can see and check the RSSI. If it's too low, let's say like it's -85, that's a strong indication that the user is not getting enough signal from the access point. And you can also run the same thing from the wireless client. There are many tools that you can use. There is a third-party application. It's called Acrylic, the one that I'm going to show you at the end of this presentation, that you can run on your computer, so you can detect the RSSI of the access points that are close by. So you can determine the signal strength for your device, and you can also determine the RSSI of other routers in case you are experiencing issues with interference or wireless congestion in your network. So another topic in the wireless environment is interference, and there are many devices that can cause you interference in your wireless network. And this ranges from power cables, cordless phones, microwaves, wireless speakers, neighboring signal from other routers in the same area. So the interference can be adjusted by either removing these devices or the material causing interference. For example, if you have an access point that is deployed close to wires that run electricity, that can give interference to the access point. So either you want to move the power cables or move the access point to a place that is far from these sources of interference. Another thing to use, especially when you have devices like microwaves, or in cases you are using wireless HDMI connectors. These devices, especially the HDMI wireless connectors, they use the same frequency as the 2.4. So if you have monitors in your environment using these wireless HDMI connectors, you definitely want to go with 5 gigahertz to avoid any interference from these devices. Another thing, always use the Wi-Fi analyzer to detect which channels are being used by other access points, so you can try to select a different channel. Because if you have multiple access points using the same channel, all of them will be competing for the time to use on that same channel, and that's what we call the co-channel interference, or the CCI. So to avoid that issue, you can run Acrylic, or you can use GWN Cloud Site Survey to detect which channels are being used, so you can try to put your access points on a different channel. Another thing is, this is especially useful when you have multiple access points deployed. Let's say you have one SS ID and you are using one access point as the master and 5 other access points deployed in the same environment. One of the things that you need to pay attention to is the radio power, because sometimes there's a difference here between the radio power and the signal strength. Sometimes you notice, you go to a place, you can detect that there are SS IDs, but when you connect, you don't have enough signal or enough bandwidth. So in this case, you have high radio power with a weak signal strength. And another example where you can adjust this, when you have a small office and you have one access point, and you notice that the access point is broadcasting the wireless signal outside your office, you can go to the radio power and you can adjust it to either a medium or low value, depending on how big, or depending on the size of your office. And of course, in large areas like in a warehouse, let's say a warehouse with only 2 access points, in that case you want to use the radio power with high. But again, you still need to do your site survey to determine whether to put it high or medium or low. Another thing also in an environment where you have multiple access points is try to avoid using wide channels. So as I mentioned earlier, wide channels, they give you the benefit of having more throughput, but they also introduce another issue, which is the noise. So when you have wider channels, you usually end up with a high SNR, which stands for signal noise ratio. So I usually would go with 40 megahertz because that's a decent, it provides you with a good, I would say a good throughput. Another thing, this option, I believe it's disabled on the GWN access point. This option, we call it short guard interval. And this option should be enabled only in good and clean environments. So first, let's explain why do you need to enable this option. This option is used to improve the throughput of your wireless connection, I would say by 5 to 10%. And what I mean by good and clean radio frequency environment is the environment should not have major obstacles that might cause signal diffraction and reflection. So in an environment we have walls made of metal, or you have any source like materials that might cause signal diffraction, try to avoid enabling this option. So with the prevalence of working from home these days, there are some best practices that users should take into consideration so that working from home can become a pleasant experience and not experience any issues. And one of the things, or the most important thing, is place the access point in a central spot. So when you roam around your house, you can always have a signal. And especially one thing to take into consideration, especially when you when you need access to your wireless connection from outdoors, like you have a backyard, and sometimes you do your work from the in the backyard using the wireless device, you need to adjust and make sure that you have enough signal strength in your backyard. Another thing also to do is try to prioritize your work traffic using the bandwidth rules built into the GWN. You can tell GWN, for example, to prioritize the traffic of your computer using either the MAC address or the IP address, or you can create multiple SS IDs. You can create one for the guests and one for your work, and tell the GWN to prioritize traffic from the SSID used by your work devices. And also, you have to be smart about which channel or which frequency to use depending on your needs. In case changing the frequency or the bands is not enough, in that case, you can deploy additional APs. And the GWN access points, as I mentioned earlier, they support the mesh network in case you want to go with the mesh network, or you can simply deploy them and assign them the same SSID and use one as the master and the second one as the slave, so you can manage all the access points from one interface. Or you can just go to GWN Cloud and manage these devices so you can have access to them from anywhere. And the last thing to avoid is placing the access point next to any source of interference. So if you have a microwave in your area, make sure you don't place the access point in the kitchen close to the microwave. If you have power cables running, make sure that the access point is not in proximity to those power cables. All right, so now I'm just going to go to GWN Cloud so I can show you the features available on GWN Cloud and how you can take advantage of these features. So this is the web interface of GWN Cloud. Again, as I mentioned, it's a free service. It's a free platform. You just go to gwn.cloud and you sign up for a free account, and you can add your devices. So as you can see here, I have 3 access points that I added to my GWN account, and I only have one client that is connected to these access points. The nice thing about the GWN is that you can manage the, multiple sites from one central management interface. And as you can see here, I have 3 sites. I have the default one, subsite, and then I have a third site. So in case, for example, you want to manage this one, you just select the subnet, and it's going to give you information about it. So let me just refresh this page. All right, so other things that you can do from the GWN is adding the access points. So here, as you can see, let me go back to status so we can look at the status of these access points. So I have 3 access points, different models, and the green dot shows that they are all online. And you can configure the alerts on GWN. So in case one of them goes offline, the GWN Cloud is going to send an alert message to your email. Some information is here. It gives you information about the firmware, the IP address, the uptime, and also the channel that is being used. So for example, this one is using channel 11 for 2.4 frequency and channel 149 for 5 gigahertz frequency. If you go to configuration, this is where you add your devices. You can add them manually using the MAC address and the password. Again, the password is the one that is included in the sticker. It's a unique password that is included in the sticker of your access points. In case you have multiple access points, you can actually add that information to this CSV templates and then upload it to GWN. Another easy way is you can use your GWN app and use the scanner option built into GWN app. So you can simply scan the barcodes so that they will be added automatically to your GWN account. So when you add devices, let's say you scanned one access point but it was added to the wrong site. It's very easy to switch these access points. You just select the access point that you would like to move to a different site and click on move. Then you choose from here the list of sites which sites you want to send that device to. So just click and then move the device. Another thing that I want to show here is under Insight and Site Survey. So I have this access point deployed here, and the access point is detecting information about the access points or the wireless devices that are in close proximity. So here, for example, it has detected close to a total of 15 access points, and it tells me which channel they are using, which protocol they are using, the width of the channel. So all of them here, you can see they're using 80, except this 120, another 120. And it also tells me the security protocol they're using, WPA2 or WEP. Let's see if there's anyone that is using WEP. So this one is open. And then important information here is the RSSI. So let me look right here. So for example, here I can see that these two access points have a good RSSI of -17, and that tells me that these two access points or these two SSIDs belong to an access point that is in close proximity to this access point. So in that case, either I need to adjust the power, the radio power of these two access points or one access point, or I can just take my access point and place it somewhere else that is not close to these two SSIDs. You can also use the GWN Cloud Interface to upgrade the phones remotely using the centralized management interface of GWN, so you can upgrade your phones remotely. Again, so you have so many things that you can do from here. You can have access to the clients, so you can have information about the their information. So let's look right here, for example. I have one device that is connected to this access point, and it gives you information about which band it's using, and also information about how much upload and download this device has used. In case you notice that there is some device that is not allowed to connect to this network, you can always go back here and block that device so it doesn't connect to the SSID. So these are the features available. This is like a quick preview of the GWN features. There are so many other options that you can use here. Now I'm going to go to a third-party application that I usually use on the computer. It's called Acrylic. This is a free application that you can download for free on your computer, and you can use it to analyze the network or the wireless activity surrounding your computer. So some of the information that it gives you is the SSIDs detected by your computer, and it tells you the MAC address of the access point and also the RSSI. For example, this access point, where is mine? Mine is this one. It's called Winson. This is only test access point that I'm connected to. So the RSSI is -61, and I'm using channel 1. Let's look at some other access points. So this one, for example, is -84. Again, the lower the value, the bad the signal is. For example, a signal of -58 or 55 is better than a signal strength of 83. So this is it for this presentation. I hope you enjoyed it, and thank you very much again for watching this webinar, and I'll see you in the next video. Thank you.